Section 5.2 is called factoring trinomials. So when we're factoring trinomials, I teach this by using what's called the AC method. And let me show you what this means. If we have a problem that we could write in standard quadratic form, ax squared plus bx plus c is, let's just leave it like that. What we're looking for is we're looking for two numbers that added together equal the b value. And the same two numbers, when you multiply them, you get a times c. And generally, we put the b value here and ac over here. So let me show you. What this would look like. After we do this, we just factor by grouping. That's generally the AC method. It'll make more sense once you see an example. So the directions are just going to be to factor. And let's say we had x squared plus 5x plus 4. All right, what we want to do is just set everything up. So the b value goes here, which would be 5. And the AC, which would just be 1 times 4, goes on the bottom. Sure. We're looking for two numbers that added together equal 5. The same two numbers, when you multiply, you get 4. Can anyone think of what those two numbers would be? 1 and 4, right? That's the hardest part of this whole thing. Generally, what I do is I take that AC number and I just think, okay, 4 is the same thing as 1 times 4 or 2 times 2. I just think of numbers that multiply to be 4, and then I look to see if they add up to be the middle. So you told me 1 and 4 are the numbers. So what we're going to do from here is take x squared plus 5x plus 4 and just break up this middle term to be 1x and 4x. This is a pretty neat technique. We always break up that middle term. So if that middle term is 5x, we break up two terms with x's in it. If that middle term is xy, we break up that middle term with x and y in it. So what we're going to do from here is just cut it down the middle and factor by grouping. Everything else is just like we did in the last section. We could take out an x, we get x plus 1, take out a 4, we get x plus 1. So totally factored would be x plus 1 times x plus 4. Completely factored. If you could do that, you could do any of these problems. They're all exactly the same. Different numbers, but those are the rules. So that's the first example. What if we did one like this? 6x squared minus 19x plus 10. So we'll make the numbers a little bit bigger. We're going to set them all up the same. 6 times 10 is 60. What numbers multiply to be 60 and add up to be negative 19? That's the hardest part. But as soon as you hit the two numbers that do that, then you're good. When you guys figure it out. All right, so we're saying 15 times 4. 15 times 4 is definitely 60, but if they're both negative, you would still multiply to get 60, but they would add to be negative 19. That's the key. If you could land on those numbers, everything else is easy. So what I'm going to do is I'm going to take the original problem, 6x squared minus 19x plus 10, break up that middle to be negative 4x and negative 15x. And then it's exactly the same as the last section. Cut it down the middle. We could take out a 2x. We could take out a negative 5. And we get 3x minus 2 times 2x minus 5. It's not a big deal, right? The trick with factoring is sometimes people learn it incorrectly before they get to me. So it's kind of like they have to learn a new technique in order to grasp it. But how many of you have ever used this AC technique before? All right. Oh, good. So maybe about half of you I'm seeing if you're in class. It's out of all the techniques I've seen, that's probably the easiest way to do this. Let me give you one more problem. Maybe I'll have you do it on your own just to make sure that you're confident doing this. What about if we had 6r squared plus 13r minus 5? Why don't you take a minute, just try to do that on your own, and then let's see if we wind up with the same answer. Remember, we always do the first times the last, and see if you could figure out what that factors to. At this point, you should have had two numbers by now. What are the two numbers that go in? Yeah, negative 15 and 2 are the numbers that do it. If you switch them, that's totally fine. We'll still wind up with the same answer. So 6r squared minus 15r plus 2r minus 5. Cut it down the middle. We could take out a 3r. We get 2r minus 5. Take out a 1. We get 2r minus 5. 2r minus 5 times 3r plus 1. Oh, it should be positive 15 and negative 2, right? All right. Looks like I made a little mistake here. So negative 15 and 2 would add up to be negative 13. But if we do positive 15 and negative 2, that would get the job done, right? So if we take out a 3r, this would be 2r plus 5. We take out a negative 1 here. We get 2r plus 5, giving us 2r plus 5 times 3r minus 1. I just want to mention, what if we didn't, let me just see what happens if we would have kept that mistake there, if we would have been able to catch it. 16r squared minus 15r. You don't have to write this down. I'm just curious if we would have seen the mistake. We could take out a 3r. Yeah. Yeah, sometimes if you don't factor correctly, these wind up being different. That's what I was looking to see. It looks like for this problem, if you don't catch it, then you'll just wind up with the wrong answer. So just make sure you're extra careful when you pick those two numbers. They have to add up to be 13 and multiply to be negative 30. So that's the tricky part. I want to show you what happens if we have different variables. What if we had p squared minus 5pq plus 6q squared? Even though there's a bunch of different variables here, that doesn't change the process. In math, if you just follow the rules, you'll get the right answer. There are 3 terms. Because there are 3 terms, we do the trinomial technique. We multiply 1 times 6. They have to add up to be negative 5, which would be, let's see here, which would be what? What numbers multiply to be 6 and add up to be negative 5? Yeah, negative 2 and negative 3. So what we do from here, remember what I told you initially, is we write the original, but then we break up that middle term. So this would be p squared minus 2pq minus 3pq plus 6q squared. So it's no different than other problems. We cut it down the middle. We could take out a GCF of p. So we just get p minus 2q. If we do the same thing here by taking out a negative 3q, you wind up with exactly the same thing in parentheses. And as long as you get the same thing in your parentheses, you're probably correct. Yeah. Sure. All right, good luck. That's how you would do that. Every once in a while with factoring, remember I joked a little bit before. It's okay. I joked a little bit before about factoring being the gift that keeps on giving. We did talk about different forms of factoring. We said when we factor, first thing we do is we look for a GCF, then we do grouping, then we do trinomials. This is what we've learned so far. Sometimes you might have to do grouping before trinomials, or sometimes you might have to take out a GCF before you do anything. So let me show you an example where that would happen. What if you had 2x squared minus x minus 12? Or I'm sorry, 2x squared minus 2x minus 12. First thing we should do to start this problem is look to see, is there a GCF of the whole thing? 2. right? We could take out a GCF of the whole thing of 2. Once we do that, then we just have to factor that inner piece. So we already factored once, but that doesn't mean we're necessarily done. We have to keep factoring. We're looking for numbers that multiply to be -6, add up to be -1. So we could use -3 and +2. So factoring this, we'd get x squared minus 3x plus 2x minus 6. Cutting it down the middle, if we take out an x, take out a 2, we'd get x minus 3 times x plus 2. And then we have the 2 outside. Want to show you 2 more. We'll do some advanced ones before we start the last section tonight. And time went fast. I can't believe we're already almost done with class here. But what about if we had 4m to the third plus 2m squared minus 6m? Just like if you were going to bake something, you don't start at step 3. Like we don't go right to trinomials, making the x. First thing we have to do is look to see what's the GCF. 2m. And then from there, we evaluate where we're at. So we could take a 2m out of everything as the GCF. So we get 2m squared plus m minus 3. And then from here, if we draw an x, 2 times -3 is -6. Add up to 1. It's similar to the problem we just had, except we're going to use 3 and -2. So this would be 2m squared plus 3m minus 2m minus 3. Cut it down the middle. Take out an m. Take out a -2, or not a -2. What can we take out of that second group? -1. We know we probably did it correctly because those inside parentheses are the same. So we get 2m plus 3 times m minus 1. I'll try one more problem here. What about this? Last one for this section is, how about 6r to the 4th minus 13r squared plus 5? Even though we have different powers, that doesn't change our steps here. First step is there a GCF of the whole thing? No, right? So we'll just go right into trinomials. 6 times 5 is 30. What are numbers that multiply to be 30 and add up to -13? Very good. Well, not -2 and 15. Because if you try those, if you add them together, you get +13, so you're close. Even if we switch it, +2 and -15, that would add up to be -13, but they wouldn't multiply to be 30. So we're on the right path. -3 and -10, I think, would get the job done. So eventually you'll land on the numbers. Think about what else goes into 30, right? 2 and 30, 1 and, or not 2 and 30, 2 and 15, 1 and 30. Eventually you land on the numbers. And then from there, it's easy. So 6r to the 4th minus 3r. Here, let me write it like this so it's a little bit more clear. We're taking the original and we're breaking up that middle term. Even though it's an r squared term, who cares? The first term is to the 4th power, who cares? The process is exactly the same. Sometimes people get stuck in math because they see a problem that looks a little bit different. We did exactly the same steps for all the other problems. The only thing that's different are the numbers. If you cut it down the middle, we could take out a 3r squared, and we're left with 2r squared minus 1. If we take out a -5, we're left with 2r squared minus 1. So we do wind up with the same things in parentheses. And that's it.